Thank you, everybody. This is the February 2022 installment of the Microsoft Data Platform Continuity Virtual Group. With me this week is a longtime friend, John Morehouse. He's going to be talking about disaster recovery techniques for Azure SQL DB and managed instance. So this is an absolute critical topic if you're actively or even passively joining into the cloud. So with that, I'm going to go ahead and turn this over to John.
Cool. Thanks, David. I appreciate it. And thanks for letting me come speak today. We are going to talk about disaster recovery techniques for Azure SQL Database and Managed Instance. I am John Morehouse. I am a principal consultant with Denny Cherry Associates. My contact information is on the slide before you. And I'm more than happy to give David and the group the slides or whatnot. As David mentioned, I've been longtime friends with him going on like 15, 20 years now. So if you need to get a hold of me, you can always reach out through David. You can always drop me a note at john@dcac.com, even if it's a question about the presentation today, or even if you have a SQL Server problem and you're stuck. I'm happy to try to give you the right direction or where to go. If I don't know the answer, I probably know somebody who does. I'm on LinkedIn, John Morehouse. Feel free to connect with me on LinkedIn if you wish. I'm on Twitter. Twitter is about the only social media platform I use these days. And I always have to qualify this. It's SQL R Us, not SQL Russ. So think Toys R Us. I know Toys R Us is bankrupt, but everything toys. I deal with just about every facet of SQL Server in one fashion or another. Don't ask me to write Power BI reports or do data warehousing cube design. That I won't do, but if you want me to support the analysis services underneath the hood, that I can do. Speaking of blogs, I do blog at sqlrs.com. My blog is usually internals. I'm that crazy DBA that likes to stay up on a Saturday night because I have no social life. Reverse engineering hexadecimal, because that's what I do for fun these days. I speak a lot. I tweet a lot. I'm honored to be an MVP for Microsoft, friend of Redgate, VMware vExpert, blah, blah, blah. Quick blurb about Denny Cherry Associates. We're a small boutique of IT professionals. We like to help you solve problems with SQL Server. If you have a project or want to bounce ideas off of us, feel free to drop me a line. For those that might not know, I lost my father to COVID in August of last year. So I'm a huge proponent of getting vaccinated, wear your masks when appropriate, get boosted, stay safe, all in the honor of my dad. So today, here's a quick agenda. We're going to talk about backups. We're going to talk about geo-replication. We're going to talk about some manual things you could do to do disaster recovery. We're going to talk about failover groups. I've got a couple of demos lined up, and I'm happy to destroy things if you all have questions. I do have time at the end for Q&A. This goes about an hour, give or take. David knows me well enough that I can turn this into a 3-hour presentation if we really wanted to, but I'll do my best to end this right about 1 o'clock. So with that, as David kind of preluded, even in the cloud environment, I still have conversations today in the year of our Lord 2022, where individuals think that when we go to the cloud, everything is just magically delicious and you don't have to worry about high availability or disaster recovery anymore because the cloud's going to take care of it. That's not really true. Really what happens is that because we're human errors still occur. A lot of the things in the cloud are automated, and that automation is written by humans. And so bugs can get injected into the automation and things can come down. Or we have what we call, in the industry usually, is the backhoe phenomenon or a rabid backhoe. You have a construction worker on a backhoe or some sort of heavy equipment, and the brake slips and they run the equipment into the building of the data center and take out the entire data center. They cut the wrong line. We've probably all experienced that. I've been in IT for well over 20 years and I've experienced it more than once. If you remember, there's been outages for AWS. Microsoft had DNS outages a while back. They had AD authentication issues. Disasters happen. So we have to plan for it as data professionals, as DBAs, because if we don't, when that disaster strikes, we're going to be left out into the wind and our customers are going to feel the results of that. Now, even in the cloud, we have challenges, and it's to some degree, it's the exact same challenges that we have when we talk about disaster recovery for on-premises. If you're a DBA and you have an premises environment, there's certain DR questions that you should be asking. And we should be asking these questions even if we're in the cloud or on premises or a hybrid of either one. Do you know how to recover the data? So if you have a cloud presence with Azure SQL Database or SQL Managed Instance, do we know how to recover the data? Do you know how long it'll take to recover that data? Because it's platform as a service, we no longer have access to the underlying infrastructure for those two products. So that changes the game in terms of if you're used to doing it on premises, there's certain things you can do in SQL to kind of get an estimate of, you can see there's a DMV that will tell you, the percentage of completion and an estimate of how long it's going to take to restore a database, for example. You really don't have that level of metrics in Azure SQL Database or Managed Instance. Azure SQL Database does have a DMV that will tell you, but it's 0%, 50%, or 100%. There's no in between. So you can kind of get an idea, but it's not really useful. What are your RPO and RTO requirements? Even in the cloud, if you have to be able to restore to meet guidelines of RPO and RTO, what are you doing to get that values or that mechanism in place to ensure that you can meet those requirements? And you can see here, these three questions are identical whether you're on premises or you're in the cloud. Now, the other thing I deal with when we talk about disaster recovery is high availability is baked into the product. The trick, though, is high availability is not the same as disaster recovery. You can use things like availability groups to provide both. You could have a 2-node cluster and your on-premises environment and your on-prem data center, and then have a third node, a DR of a virtual machine in Azure. So you can function both. You can use that product to supply both high availability and DR if necessary. But the products themselves have high availability baked in. So high availability, and the way that I classify it, is usually within the same data center. So if I've got a virtual machine in a region in Azure, and I will premise that I talk primarily about Azure. Everything's Azure here. If I put it in the same region, I don't know exactly what data center that might be going, but I want my disaster recovery to be as far away as possible. And we kind of already talked about how you could use availability groups to include a DR methodology. But I want my DR greater than 100 miles away from the primary data center. If you have returned to your office and you can look out your window and see your DR data center down the block, way too close. I want that data center hundreds of miles away, across the nation, across the globe, whatever. And in today's world of the cloud, you can actually facilitate that for the most part relatively easily. If you're old like I am, you remember back in the day when facilitating a true DR scenario was months and months of legwork and pain. You had to rent physical space somewhere. You had to rent circuits from Quest or whoever your telecoms provider was. You had to set up routers on both ends. Somebody from your IT staff had to physically take server racks and server equipment over to that DR center. And most likely by the time you got that DR center stood up and ready, that technology was already out of date and it was time to refresh. There's a whole, vicious cycle that just went round and round. So I want my DR at least 100 miles and at least in a different region within the cloud. I like, for example, if my primary is on East US, I will do Central US in Azure or West, because if I have anything that is, especially like on the East Coast, we deal with further on the East Coast than where I am, we deal with hurricanes. So hurricanes can be a pretty strong force of nature and take out data centers. I want my data somewhere else that I can facilitate a failover to far away. Also with DR radiuses, we have to think about how are we going to get the data there. Usually in a disaster recovery scenario, most of your replication is going to be asynchronous. The solutions that Microsoft provides natively is all asynchronous in a day-to-day environment. When you fail over, it actually flips to synchronous to ensure that the data is committed and we don't have data loss. But like if you have a 3-node availability group, you could have the 2 nodes on premises be synchronous for high safety, and then the replication traffic from the on-premises environment to the DR node in Azure could be asynchronous for high performance. So we have to think about how we're going to get the data there. The other thing I will say is that DR is not intended to fix any sort of performance issues. I've actually run into issues where individuals or organizations think that DR is somehow going to magically think that your OLTP loads are going to run faster, or you're going to sell more widgets in a faster manner because you implemented some solution for disaster recovery. Disaster recovery is not fixing performance issues. That's a whole different ballgame. Disaster recovery is about ensuring that we can meet those RPO and RTO values and make sure that our clients can buy those widgets, because it's really all about me. Because my customers can buy widgets, then our sales go up. If our sales goes up, my bonus structure goes up and I make more money. It's all about me. So with that, how do we choose the right donut? So because I'm on a diet, I have to have a slide about donuts here because I'm a huge donut fan. And I, of course, want all the donuts. So we can't really choose all the donuts because there's a cost threshold there, right? So the more donuts you choose, the higher your cost is, and we want to keep costs down. We have to at least evaluate all the methods so we can figure out what works best. Now, some of these methods, I'm going to mention them. For example, like we can do manual things to facilitate a disaster recovery solution. I'm not sure that I would recommend the manual ones, but as a one-off, maybe. We can restore from backups. So thankfully, the platform as a service kind of handles backups for you automatically, and we'll talk about that. We can do active geo replication in certain scenarios, and we can talk about auto failover groups. So, and I've got demos of the last 2, and we can kind of look at a demo at a high level of a restore, just so you can see what that looks like in the portal if we get to it. So let's talk about the manual options. If you've ever messed around with Azure SQL Database and gone into the portal, you can actually export the database. And the export is based off of, if you remember way back, 2005, 2008 timeframe, they introduced DAC packs and backpacks, where you could actually right-click a database and say export, and you could export the schema or the schema and the data into a XML file that is then deployable elsewhere. So you can actually go into your Azure SQL database, go into the portal, go to the database, and say export. And you can actually export the backpack, which is both the data and the schema, to a storage account within Azure. So you can do that. It's not very versatile as your database gets bigger. So what I have seen is on really small databases, it's not bad, but it is a manual process where you as a DBA or somebody has to go in the middle of a disaster and go export and hope that it actually finishes and exports successfully. What I have seen is as the database size gets larger, 500 gigs, terabyte in size, that export process tends to fail and not be overly reliable. But it is a valid option that you could say, hey, I want to take an export of it. I'm going to save it off. I'm going to do deployment. Let's export it before we do the deployment, and we're good. And then you can actually bring that export down and mess with it. You can do ETL. Again, it's a manual option where you have to write Azure Data Factory. You have to write an SSIS package. You have to facilitate the inner workings of that ETL to capture that schema, capture that data, whatever is important in your DR scenario, and then do something with it. Again, would have to be, you wouldn't want to do this in the middle of a disaster. So you would have to pre-plan this and then keep it updated. This is probably my least favorite thing, but again, it is an option. I mentioned copy-only backups. The only thing you can do here is you can't do this with Azure SQL Database. We can't manually take any backups of Azure SQL Database. In SQL Managed Instance, you can do a copy-only backup to an Azure storage account. So you can take that backup and then move it to another managed instance, some other things. It's kind of limited into what you can do with it, but at least you'd have a backup there. I know some clients that we do take copy only backups because then they are doing some sort of DevOps work around that. And speaking of DevOps, you can DevOps everything. DevOps is the new buzzword and has been for a while. Everything is DevOps. And so if you have a DevOps pipeline and can automate some things, maybe you can automate doing an export or a copy only, or you can find some other flow within the DevOps to facilitate that. You could do that type of process. All of these are manual. I'm a lazy DBA. I don't like overly manual things. If I do it more than once, or if I have to worry about it, I'm going to automate the crap out of that. I'm going to use PowerShell. I'm going to use Azure CLI, automation accounts. I'm going to do something to get my hands as a human out of that process, because I'm going to screw it up at some point in time just because I'm human, right? So those are the manual options. I don't like them, but they are valid. But so take that with a grain of salt. Any questions? I do like questions. David's going to probably save them to the end or interject whenever, but I'm going to take a drink of coffee. Okay, so let's talk about restore from backups, because this is a DBA. This is what we are more familiar with. But as we move into the cloud, we are limited to what we can do with backups and taking backups and whatnot. Because the two products, Azure SQL Database and managed instances, are, there's a chat. Oh, cool. Never mind. It was just David. Because the product is platform as a service, we can't, other than the copy only backups and managed instances, we can't facilitate the backups of the databases. So thankfully, because I'm lazy, and this is one of the aspects of the products that I absolutely love, is that if you create a brand new Azure SQL database in your tenant, your subscription, the backups happen automatically. I don't have to do anything to facilitate that. And so, like, I've got a client that is 100% in Azure SQL Database. Their app dev teams will spin up new databases in the lower environments to do application work. And I don't have to worry about ensuring that those backups are actually happening, because the service does it for me. Right out of the gate, you get 7 days. Oh, my clicker got out of focus. It's still out of focus. Why is that out of focus? There we go. Right out of the gate, you get 7 days of point-in-time recoverability by default. So that comes along with the price of the product. So whatever your storage, your CPU costs, all that, you get 7 days of point-in-time restore. So I can go into an Azure SQL database at any point in time within those 7 days and say, hey, restore to this exact day, time, minute within that 7 day window. You can extend the point-in-time restores up to 35 days. So take, for example, my client again, they determined that they don't need long-term retention of their data. 35 days, they aren't going to restore anything beyond 35 days. They are in the mindset of, we're going to roll forward, meaning we're either going to restore within that 35 days, or we're just going to roll forward, fix the issues, and move on. We're not going to worry about restoring back to the previous year, previous 6 months, whatever. As a DBA and as a consultant, I very rarely will recommend my clients retain long-term stuff, except for like audit purposes or security reasons. Rolling back to a year ago would be super painful for just about any organization to lose that much data in a production environment. If you're restoring to a lower environment, whatever, that's a different story. But you can also store, and I kind of mentioned it, you can configure long-term retention for your full backups for up to 10 years. You can't do a point-in-time restore beyond that 35 days. There's no way to configure the platform to say, hey, I want to be able to do a point-in-time restore from 6 months ago. You can't do that. What I can do is configure either product to say, hey, I want to take the weekly full, and the backups happen a weekly full, and it happens once a week, and there's 2 daily differentials. And you can actually specify the differentials to be 12 hours apart or 24 hours apart. And then transaction log backups happen about every 4 to 6 minutes, depending on your workload and how busy the compute nodes are and whatnot. But that's basically this backup schedule. I can say, hey, I want to keep the weekly fulls for every week for up to 10 years. There's an additional cost to that long-term storage. You actually have to specify a storage account, and I don't think you specify a storage account, but you configure the long-term retention, and we'll take a look at it in the portal when we get to there. So I can keep that data for 10 years, but you have to pay for it. You can specify that long-term retention, and it's geo-redundant for backups. And so by default, when we take the backups, because Microsoft is really smart, the storage is already geo-redundant. And so as we write the backups, that backup is automatically replicated to a different storage account in a different region. Usually it uses the sister region for that given storage. So like if I, and I don't know this for a fact, but if I were to use East US as an example as my primary, I write the backup, the sister region is West. And so West would actually have a replicated copy of that backup in case East US goes down. Now you can specify, hey, I don't need geo-redundant storage. This is relatively new. You can specify, hey, just keep it local. And this is a great way for your non-prod, your test dev environments. If you don't want to incur the cost of that additional geo-redundant storage, you can just say, hey, just keep it local. That's enough for me. I don't need anything else than that.
Can you restore that point in time to a new database?
Can you restore a point in time database to a new database? So I actually will talk about that in just a second. Great question. Give me two bullet points and we'll talk about that. So as much as I love the restore, you have to restore in the same subscription as the source. There's no, I take that back. There is a workaround, but if you restore, if I go to the portal and say, hey, I want to restore a point in time, you have to restore to a point in time to the same logical server. So when you go into the portal and you're dealing, and this is specifically actually both products, you have to restore to the point in time to the logical server. The process won't let you overwrite the existing database. And so to your question, you have to do a point in time to a new database. Either you have to blow away the existing one and let the process recreate it, or what I tend to do is restore it to a new name, rename the old one to something else, and then rename the one you just restored back to the original name. That solves kind of two different problems. Because one of my clients, we had to do this recently because they had deployed a problem and actually corrupted a bunch of data. So the only way for me to fix it was to actually do a restore in Azure with their Azure SQL database. By doing that process, I'm leaving the existing one in play and online and totally functional until that restore gets done. Then once the restore is done, it's just a name swap that is relatively metadata. Is as long as you can get a connection to the database and can make that change, it's pretty quick to do that. The other thing is you'll see the bullet point on that top bullet. I meant to talk about it. Because you have to restore in the same subscription, if you want to do if your production environment is in one subscription and your lower non-prod environment's in a different subscription, if you work in an organization where they do a refresh from production down to the lower environments, that becomes complicated because they're no longer in the same subscription. But I recommend different subscriptions from a security control perspective. And so it kind of makes sense. You can use, Azure does have a product called a resource mover in which you could restore to the same logical server and then use resource mover to move that database from one logical server to another across subscriptions or across regions. So you can use the resource mover to move that database if you really wanted to do that. Other than that, it's kind of difficult to get it across subscriptions. We can restore long-term retention backups across regions. So if I do have that long-term retention backups set up and configured, you still have to be in the same subscription, because I just tested this past week, but you can at least restore that database to another logical server within the same subscription. So you still have to stay within the subscription, but I can set up a new server in West and restore that long-term retention across there. The other trick with the backups, and I mentioned it earlier as we kind of got started, we don't have any good way to identify, okay, how long is this sucker really going to take? Large database restores can take upwards to 12 hours. I have mixed results. I've restored a couple 100 gig database in 45 minutes. It depends. And the reason for that is because it depends on how busy is the region? How busy is the logical server and the compute nodes that you're sitting on? All of that. And because the backups are in a different space, right? They're in an Azure storage account. There's network latency. We have to pull it across the fabric of Azure. Yeah, it's pretty robust, but you can't beat the speed of light. I don't care where you are. So large database restores can take a lot of time. This is where it comes into question about when you start to think about disaster recovery in the cloud. How long is it going to take me to restore that database? And what's the process? Because again, we can't overwrite the existing one. So we have to restore it somewhere, do a name switch, and that all takes time. And when you've got the CEO over your shoulder, it's even worse. With managed instance, we're talking about restores from backup. We can't restore the entire instance. We can't, it's by database. We can't just say, hey, here's a managed instance, restore the whole darn thing. We can't do that. We can restore copy-only backups for managed instances. So we can use a copy only to move that around if we wanted to. So we do have that possibility. And as I mentioned already, you can't overwrite any existing databases in either platform. So again, you got to take that time into consideration as to how are you going to restore it. Restore it to that logical server, do a name swap, do whatever, drop the existing one, whatever. And you'll see it in the portal. It'll actually append a date time stamp as to the new database name. And you can change that in the portal before even kicking off the restore. Managed instance has a little bit more flexibility with the restores. What I really wanted to point out here is there's a couple different ways that you can manage resources in Azure. You can do it through the portal, which is pretty robust. You can do it in Azure CLI. You can do it in PowerShell. You'll note here that PowerShell, though, is capable of doing all four things for managed instances. We as DBA professionals really need to learn some level of PowerShell or command line language, because there are things in Azure, not just this one, that we can only do within command line. A good example is if we wanted to do a storage account policy with a SAS token, we have to actually create that with PowerShell. We can't do that in the portal. There's no other way to actually generate that storage access policy with a token, a SAS token, other than running a PowerShell script. So we as DBAs, I know some of us might be allergic to it, but we need to learn PowerShell or some sort of command line. So that's restores. Any other questions about restores? Because we're going to jump into active geo-replication. I don't see anything in the chat. Far. All right, cool. 12:30, I think I'm doing good. So active geo-replication, it's only for Azure SQL Database. So you can't do geo-replication for managed instance. You can replicate data from one region to a different region. You do get a readable secondary copy of the database. So it is online. You can read it. You can offload reports to it. You can offload pretty much anything you want to, as long as it's just readable. You can get up to 4 secondaries. So I can specify replication to 4 different secondary replicas if I wanted to. What's kind of cool about this, though, is that I can actually daisy chain the replicas. So I can replicate to server A, from server A to server B, then replicate from server B to server C, and so forth. There is a limit, and there is going to be latency, obviously, between, by the time it gets down to the bottom of the waterfall, if you will. but you do have that ability to specify that. Now, with active geo-replication, we get automatic failover only by user or application intervention. And what I mean by that is I have to design my application to be smart enough to say, hey, we have an outage, we have something going on. I'm going to, me as Mr. Application, I'm going to go into the database and tell it to fail over. Or an end user, a DBA, somebody has to say, yeah, we're having an issue. We have to go manually click a button. We don't have automatic failover from the service fabric in terms of Azure to facilitate that failover. So because I'm lazy, this gets me a little bit closer because I work with some really smart application developers. They can facilitate this process and just let it fail over and I don't have to worry about it. It's super quick to configure. Underneath the hood, it actually uses availability groups behind the scenes. So if you've used availability groups with Azure virtual machines or on premises, the concepts are kind of just the same. It's slightly different because it's in the cloud. It is asynchronous in nature. And so what happens is that everything is asynchronous until you want to do that failover. When we do that failover, the process will actually flip to synchronous to make sure anything in flight gets committed on the secondaries, and then it actually just performs the failover. So it's pretty simple to configure. In my demos, we'll actually configure not only geo-replication, but automatic failover groups. And you can see with a couple clicks, I can get a database, an Azure SQL database into a DR solution within just a few minutes. This is what the topology, the infrastructure topology looks like. We can actually see that we've got, the primary region on the left. And this is where I would specify, okay, my primary is in East US. I'm going to go ahead and put my secondary Central US, West US, somewhere else well outside my primary region, just in case the primary region just ups and walks off. And geo-replication is actually the basis for automatic failover groups. Automatic failover groups, let me back up. Active geo-replication is defined within the individual database. The auto failover groups is defined at the server level. And it provides read-write endpoints. So take, for example, my client that is 100% Azure SQL database. They actually use those read-write endpoints to facilitate automatic direction. So think about the endpoints as the availability group listener. So if you have a listener, you can say, hey, I just need read access. I'm going to hit a specific endpoint, and that endpoint in Azure, it's just a DNS. It's I think it's Traffic Manager behind the scenes. The endpoint is going to say, hey, you're reading a read-only endpoint. I'm going to automatically direct you to the right replica that is the secondary. And so all of their connection strings are pointed correctly to the right endpoint. If they need to write data, it's going to the primary replica to actually write the data. It is limited to certain regions within Azure. And failover groups has a 1 hour minimum grace period. Now, this grace period is from the Azure Fabric itself. And it kind of makes sense as to why they put it there. The failover groups, I mentioned in geo-replication, active geo-replication is user or application managed, meaning that I as a DBA or the application has to go and initiate that failover. With auto failover groups, that process is now automated by the service fabric itself. So Azure will monitor and say, hey, you have an outage, you have a failover group set up, we're going to start the failover process. The grace period is there. And you remember that with geo-replication, I said that it's synchronous by nature, and the failover groups are also synchronous, or asynchronous, because the auto failover groups is based off geo-replication. When that failover happens, it flips from asynchronous to synchronous. It's going to wait an hour. That's the lowest granularity you can get to ensure that any data in flight gets committed and hardened to the secondaries before it actually does the failover. The service fabric isn't smart enough to know, hey, you have a really busy server, but you still got transactions in flight. So we're going to wait 5 minutes versus an hour. And so Microsoft just said, hey, we're going to give you an hour. If you need it sooner than that, you can go in and manually do it. Otherwise, the service will wait an hour, allow everything to get over to the secondary, and then actually do the failover. And that really helps to minimize service interruption. But in that time, you could be down. So me as a DBA, I have alerts set up for most of my clients. If Azure is having issues, I can then manually go into that failover group and say failover. And then it would bypass that 1 hour minimum grace period because I manually went over and failed things over. From an infrastructure perspective, kind of different than what we saw before with active geo replication. You will see that the failover group is on top of that active geo replication there in the middle. And the difference is we also have those read, write, listener endpoints. And I'll show you those in the portal. This is kind of what they look like. And so like for my example, I've got demo 2 in East US 2, and I've got a secondary in North Central. The read, write, listener endpoint, if I had an application, I could point it to that endpoint, and then it would be routed to the right one. In the failover process, those switch. It's just a DNS switch behind the scenes. And so your applications don't have to change. Now, with geo-replication versus failover groups, you can see here that geo-replication doesn't provide automatic failover. The other thing with a failover is, and I just mentioned it, the geo-replication, if you do a failover, you have to go update your connection strings in your application. With failover groups, you don't, because those read, write, listener endpoints, as I said, just a DNS switch behind the scenes, you don't have to worry about that. I can do multiple replicas with geo-replication. I can't with failover groups. It's a one-to-one, right? I've got a primary and a secondary, and that's it. I can't do anything with that. But you can do it with the failover groups. You can still have that readable secondary. You can use that all day long. So managed instance, any question? No question. I'm going to take a drink of coffee. Got any questions? Ask. Cool. Failover groups, we have a different architecture. Now, with managed instance is a different beast behind the scenes because we have much more granular control. And managed instance really was Microsoft's answer that sits between Azure SQL Database and on-premises, right? And so it is that morphed solution there in the middle that we still don't have access to the infrastructure behind the scenes, but we have a full SQL Server Management Studio look and feel. So we can see TempDB, we can see Agent, we can see the system databases for the most part. We can do a little bit more things with managed instance. And so it's built a little bit differently. And it's also built differently when it comes to like failover groups and disaster recovery. I can use different subscriptions for failover groups with managed instance, as long as those subscriptions are in the same tenant. I can't go across tenant. The other thing is that with a failover group, it's all or nothing. And so just like with Azure SQL Database, the failover group is created and managed from the logical server perspective. Same thing goes with managed instance. So if I set up a failover group for a managed instance, I do have one set up already, so we can take a look at it. If I create new databases on the primary instance and it is in a failover group, that database is going to be automatically replicated and created on my secondary. I don't have to do anything about it, which is kind of nice. I don't have, as DBA, it just is magically delicious. Somebody creates a new database, it gets transported and replicated over to the secondary. I still have that readable secondary endpoint, just like I do in Azure SQL Database. And I still have the exact same grace period in terms of a failover. I can manually go and force that failover just like I can with Azure SQL Database. So me as a DBA, I still have that capability to do that. If I make the decision, hey, yeah, we're good. I don't have that much traffic going. I can just force that failover. And the architecture is a little bit different. You will see here that we still have the failover group based on that geo replication. There are things like you'll notice there's a DNS zone, and I think I've got a bullet point here coming up, but I can talk about it now. The managed instances has to be within the same DNS zone for the failover groups to work. And what that means is that we have to, now as a DBA, we have to be a little bit more smart in terms of how we set up and configure the managed instances. And if you've never taken or created a managed instance, you will find that it takes a lot of time to create. It is not a simple thing. With Azure SQL Database, the process to create a failover group or even the database itself is relatively quick. I can spin up a database within a couple minutes. On average, to create a vanilla out of the box managed instance, 4 to 6 hours. And that is without a failover group. If I need a failover group, I have to create 2 managed instances. So if you're going to create them at one at a time, you're talking anywhere from 8 to 12 hours to create both managed instances. And what's even worse is if you screw up, you have to destroy the managed instance, most likely. It takes time to destroy the managed instance. It is not a simple destruction process. That destruction can actually take several hours, 4 hours to trash. I gave this presentation not a couple months ago, and I was setting up the demos. And so I was actually setting this up, and I screwed up. My secondary was screwed up, and it took me 4 hours to destroy that secondary so I could recreate it, which took another 6 hours, right? And so it is not a quick thing. If you have an Azure SQL database, I can set up a failover group pretty quickly and get your data starting to replicate elsewhere pretty quickly. I can't with managed instance. So it takes time. You have to pre-plan this. It's significantly more complex to set up and configure. We do have to have, because we're in the same DNS zone, but we have different requirements in terms of networking. We actually have to either have a VPN gateway, or we have to do global VNet pairing between the 2 VNets that the 2 managed instances are sitting in. So this, and I'm not a huge networking person per se. I know enough to be dangerous, but I will say that dealing with Azure SQL Database and more so with managed instances, it has caused me to learn more about networking in general, especially from a cloud perspective, because me as a DBA, I have to make sure that this is set up right so that my clients and whatever's using managed instances is done correctly. And you can't remove a secondary without actually destroying the failover group. With Azure SQL Database and a failover group there, I have more flexibility of moving things in and out of that failover group. With managed instance, because it's so complex, if you remove that secondary, you're going to destroy the failover group along with it. So you're limited to what you can do. There's some other limitations and gotchas. Both instances must be the same size. And so if you start off with one size, they're skewed in terms of their size, compute and storage. You have to get them to be the same before you can actually create the failover group. You can create, 2 instances simultaneously and then do a failover group, or you can, actually through the process, create one and create a secondary and say, hey, the secondary is now a part of this failover group. But know that scaling managed instance is not a necessarily fast thing. I scaled an instance in terms of compute and storage, and it took 5 hours. So that in itself can be something that you have to take into consideration as well, as that scaling process just takes time. As I mentioned, it's got to be in the same DNS zone. Microsoft recommends to use paired regions for your performance. You don't have to, but the paired regions are there for disaster recovery and high availability from the 2 regions within Microsoft. And so the service fabric between those 2 paired regions are a little bit more robust. And so they recommend using the paired regions. The other trick is your IP space can't overlap. Ask me how I know. And it's all related to when I did this last time and I screwed up. The 2 managed instances can't share the same IP space, even though they're in 2 different VNets. They have to be of different IP spaces, which, if you're not a networking person, can be irritating and cumbersome, but that is a gotcha that you have to be aware of. So if you are planning to do failover groups with managed instances, you have to think about that in terms of a networking perspective. Hopefully you have a network admin who is better at networking than I am, but you can't have IP spaces that can't overlap. Okay, with that, demo time. No questions. So I'm going to flip screens, and I apologize. My demos are over here, and so I'm going to be looking over here and not at you. Okay, I assume that you all can see my screen. Can you see my?
Yep, looks great.
Cool. All right. tidbit, and I'm going to share this with the rest. We were talking about this earlier. Logical servers in Azure SQL Database are globally unique. So you can domain squat on a logical server name. Nobody in the world can own empire.database.windows.net because I'm squatting on it. A logical server is 100% free until you put a database on it. Tidbit. Okay, so I have a server here, and I hope that the Zoom settings are okay. Everybody can see this. I have a logical server, SQL DB Demo 2. This server is sitting in East US 2, and I've got a couple databases on it. Primarily, AdventureWorks is what we're going to be dealing with today. It is your normal sample AdventureWorks 2017 database from Microsoft. This is what I use for most of my demos. It is a general purpose 2 vCores. But so let's talk about backups first. Backups are configured at the server level. And so we can actually see that down here in backups. We can see that I don't have, that's interesting. I should have had, oh, I do. Okay, cool. Here we can see that right out of the gate, where my earliest point restore point in time is. So I can go back point in time if I needed to. These databases, these three, this one, and this one, these are currently offline. They are paused. They are in a serverless state, and so they are paused to help save me money. This one is actually configured to be provisioned, so it is always up and running. And I was doing that for a demo. So if I wanted to, I can actually change my retention policies. And so if I come into the database, configure policies, we can see here that I can now change my point in time from 7 days and scale that all the way up to 35. If I just take that slider, move it all the way to the right, this number will change from 7 to 35, and click apply, and it's that easy. And then the service will automatically start to retain those point in time backups, the transaction logs, the differentials, all that for up to 35 days. As I mentioned, I can change my differential backup frequency from 12 hours to 24. Maybe I don't want to incur that additional storage for that differential, for 2 differentials per day. So I can change that. And then down below, I can change my long-term retention to say, hey, and like right now for AdventureWorks, I am keeping the weekly full backup for 1 week. If I wanted to, I could change this to say 52 weeks, however long I need to. I can change this value from weeks to years to months, whatever. And same thing for I want to keep the last monthly full backup for however long. Or if your organization's big into audits and I want to keep the last annual full backup of the year, so think December 31st at 11:59 p.m., I need to keep that for 5 years. I used to work for a financial organization, and we would take a annual full backup, and we had to retain it for a number of years. I think it was 3 or 4 years. I can configure that within the portal relatively easily and just say, yep, apply, and I'm done. That's one of the things I love about the platform as a service products. It's really easy to kind of do some administrative stuff that we used to, we'd have to write scripts, we had to write a schedule, we'd have to, if the job fails, we got to do something. The Service Fabric just takes care of it for us. Makes my life easy. And so that's long-term retention. And so we have that ability. If I wanted to restore the database, I can actually create a database. We'll go into here. Come on, computer. So you'll notice that one, it already pre-defaulted the resource group, the database name, and what server. I'm actually going to click over to my additional settings just for time. And so I can actually say, hey, my data source is going to be a backup, and I'm actually going to restore my point in time. This is my point in time. I'm going to restore my point in time. And you'll notice the other thing, as soon as I select that point in time, it automatically defaulted the database name with a timestamp. And so this is where you can actually change this. I can change this to whatever I want. I still can't overwrite the existing database. If I try to do that, the portal is going to tell me pretty much to pound sand and we're out of luck. So I have to either leave the default name that was generated, or change the name here, right? New, and then go back and do the rename thing once the restore is done. And so I can actually like kick this off. My estimated cost, blah, blah, blah. I'm going to use Geo. Once it's restored, I'm going to start using the Geo redundant. And so I can actually kick this off. And so now the service is going to go out, go find that point in time backup, figure out all the log chain, and start the restore process. And so we can actually watch this. And if I come back here later within the next few minutes, it might be done. I don't know. You will notice there's nowhere in here that says, hey, an estimated recovery time is 30 minutes or an hour or whatever. This goes back to your RTO and RPO. How long is it going to take you to restore 500 gigabyte database, terabyte size database in your cloud environment? Those are things that you want to practice. Just so you have your timings down, especially when your CEO's over your shoulder. You can say, hey, on average, it took 15 minutes. And so we should be back up and running within 15, 20 minutes, whatever that might look like. Now, if we look at the database, so that's long-term retention, that's restoring. So now I've got a database restoring, and eventually it'll show up in the control plane of my logical server. If we go into the database, and remember that geo replication is configured at the database level, I don't have any replicas set up, but I can create one. So if I wanted to create one, you'll see that it's pretty much everything's ghosted out. In terms, I can't change the database name. It's an availability group behind the scenes, which makes sense. My primary region is the East US 2. I already have a secondary server set up in West US. And so I can create a new server here. I'm going to leave my compute and storage all the same, not a problem. Here, I don't care about geo redundant of the secondary because the secondary is going to get backed up too. So you're going to have duplicate backups of both servers. I'm going to go ahead and create this replica and voila. And so I've actually started geo replication. And so right now the service fabric is basically seeding, using automatic seeding and taking a backup. It's going to restore that backup over to the secondary for all intents and purposes, start the replication stream, and then eventually come online. And so if I go back to the database, and we can see that right now it is seeding. And so I'm going to have my primary be in East US 2, and then my secondary is going to be in West US 2. So once that seeding is done, that database is going to come online in a readable secondary, as a readable secondary, and then I can go do stuff with it. I can see it, I can delete it or whatever. So it's that simple. I took, 2 clicks, 3 minutes to at least start the process. We can at least start the process to get things replicated from point A to point B. And it's going basically from Virginia to Oregon-ish. East US 2 is in the Virginia area. West US is, I want to say Oregon, Northern California, if I remember right. But so I'm actually replicating the entire database across the continental United States all pretty quickly. And here, this is where I go back to I'm old. If I remember the days of previously when we had to do DR, it was a 6-month project and somebody had to physically go there. I never left my office. I'm still here. And so I can watch this. Ooh, I succeeded. I refresh that. Oh, so my database is now online, and that took all of 4 minutes to do. Pretty easy. I think it's fantastic. It's a fantastic solution for DBAs to ensure we have disaster recovery set up. If I wanted to, I can now come in here and say, hey, I want to force a failover. If I force the failover, it's going to fail over right then and there. That's one of the downsides about geo replication is if you have anything in flight, you might lose it. But I'd rather force a failover than not have the option to fail over at all. So even if geo-replication is your solution that works best for your organization, I would 100% support that rather than not having any solution whatsoever. So that's geo-replication, super simple to put in place. Failover groups. Let's go to failover groups. Failover groups, as I mentioned, is set at the server level. That's the scope of where that needs to be created. If we go into the server blade and scroll down, we will see we have the failover group option. I actually have one here, but I'm actually going to create a new one because I don't think this should have been empty. It is. John's demo 2. I'm going to select my secondary. Now, you'll notice that really the failover group is really, because failover groups are based off geo-replication, I've already got the replication in place. And so what should happen here is, because I'm going to create a failover group, the failover group really is just a DNS thing that lays on top of the geo-replication. The geo-replication is what is the workhorse of this. But I should be able to select the database. We can see my grace period, right? This is where the service will do the failover for me. And if I have a super transactional system, highly volatile, very sensitive, this is where I would maybe recommend, okay, let's change this to say from 1 hour to say 10 hours. I can facilitate that, allow the service to do it, whatever. But you can change that for up to 24 hours. I can come in here and say, hey, I want my grace period to be 24 hours. I'm going to leave it at 1 hour. I'm going to create. So we've started the deployment. And so the service fabric right now is going to go create the DNS entries behind the scenes. That really was probably a red herring. Thought so. I've noticed recently that you might get, hey, the deployment succeeded, when in reality, it's still in progress. I actually need to send this to somebody at Microsoft to say, hey, you guys need to go fix the portal because it's kind of messed up. So right now it is deploying the DNS endpoints for that failover group. It's going to put the geo-replicated AdventureWorks 2017 database into that failover group. And then when this is really done, I can actually go in and show you a failover. Oh, look, it finished. So if we go to the database, that's the failover group. Let's go back to the server. Dun, 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 dun. SQL Demo 2 is my primary. I'm going to go to our failover groups. Demo 2 is the one I created. So we have a couple things here. Whoops, you guys can't see that because I masked it out. Here's my endpoints. And so I have a read-write listener endpoint that my application can go hit. I have a pretty nice graphical representation as to where my replicas are sitting. I actually don't like that they use green for the secondary. I want green for the primary, but for some reason the blue is the primary. So I'm replicating my data, if I make a change to the database, all the way across the continental United States, and it's pretty quick. The latency is pretty minimal thanks to the robustness of the Azure backend fabric. But I can come in here and say, okay, look, I want to do a failover. I'm going to failover. And we can see right here, East US 2 is my primary. My West is secondary. I basically told again, availability groups, I've told the service, hey, go ahead and do a failover. So right now, the availability group behind the scenes is initiating that failover. In the middle of the failover, my East US 2 database is still online until it's ready to do that failover. That also happens when I do a scaling. So if I do a scaling event with Azure SQL Database, the service will actually do a secondary node somewhere else, seed the database, and then do a failover. That's why a scaling event, your primary stays available until it actually does that failover. And voila, we can see that my dashboard has already switched. My primary is now West US and my secondary is East. I did that with a couple mouse clicks. So that's pretty simple from an Azure SQL database in terms of standing up a DR scenario. And my client that is 100% Azure SQL database, every single one of their production databases has the ability to do this. And so their databases are in a failover group. and they are configured, and you can have multiple databases in a single failover group. So just like if you have a enterprise SQL instance on premises with an availability group, you can put multiple databases into that one group. You can do it here as well. Just like with on premises, though, if you fail over the group, they're all going over. In their case, they actually decided they wanted the granular ability to fail over one database, have one database in one region and the others in somewhere else. That was their decision to make. But you do have that flexibility when you do this. So really easy to do. So there's that. I'm like 3 minutes over, but we're almost done, I promise. Okay, so that was geo-replication and failover groups for Azure SQL Database. We kind of looked at backups as well. Let's take a look at managed instances. You can see here, I have two managed instances, East MI and West MI. Obviously, the East one is on the East US and the West is on the West US. You'll notice that they are in different subnets. They are in different VNets. So if I go into, my primary right now is the East MI one. Same kind of concept. If I go into the server blade, go to failover groups, it looks very familiar, right? We have a nice topology map of, here's my primary, here's my secondary. I have the same issue. I want those colors reversed because I'm the paranoid DBA. I still have my endpoints. You will notice that the endpoints are slightly different. We have this weird number, and that weird number is actually the DNS zone. So if you remember that with failover groups with managed instance, you have to be in that same DNS zone for the networking piece to work correctly. You can make this, let me back up. The managed instance can have a public endpoint, meaning you can get to it just like you can Azure SQL Database with a network security group, a firewall. The one downside about these failover groups, I haven't found a way to make this publicly accessible. So if you have managed instances in a failover group and you want to use these endpoints, your applications, end users have to be within the same VNet, on a VPN to the VNet, or they have to be within the same confines as these endpoints are. I haven't been able to find a way. I've actually got an email into the product group of saying, hey, what if I want to make that publicly accessible with a network security group? There's no way to do that. Not any way that I found anyways, not yet. But still pretty easy to utilize. You can take this. If I want to do a failover, it's already set up. Again, it took me 12 hours to get this all configured right. Do a failover. Yes. Two mouse clicks. I have now instituted a failover of my production managed instances from one coast to the other. And so here in a few minutes that should finish, and my secondary will be East, and then my primary will be, oh, see, look, it already switched. You guys see that? So this is the failover group name. It already switched. Again, it took 2 minutes. Now, I've only got one database there. So if I had multiple terabytes of databases, that failover might take a little bit longer, but it's going to be synchronized anyways. So it shouldn't be that long of a latency to do that failover. So you can see how easy it is. Even with managed instance in the upfront, you do all that hard work up front, getting things set up and configured right and whatnot. But it's super easy to control that failover and to manually kick that off. Okay. Any questions about that?
Nope. No. This is awesome.
Cool. All right. That's pretty much all I had for demos. So is there anything that anybody wants to see before I move away from the portal? Do you want me to break anything? Do you want me to screw anything up? Because I'm happy to do it. Okay, no. Okay. So one of the big things with any disaster recovery solution, test it. Please, for the love of God, test it. My client, again, I use them a lot because they're 100% in Azure SQL Database. They will do a failover. They will go and institute a failover to make sure that their application can handle the transient error. That's another key takeaway. Because it's a failover, just like on premises, your applications have to be able to withstand transient errors in that failover moment. If it is super sensitive to that disconnect, the couple seconds that it's going to lose connectivity to the database, you highly recommend that you fix that. Thankfully, their application is pretty robust, and it can easily handle the failover from one region to the other and just pick up right where it left off. The end users see very little disturbance in their application to facilitate that. But if you don't test it, if we don't answer those questions up front, get things configured, we're going to be in a world of hurt when that rabid backhoe does come along and takes out a data center. It happens. It just really does. You'd be surprised at how many times I have conversations with people and they think that it's going to be just magically delicious because we're in the cloud. It doesn't work like that. Okay, so a quick summary and then I'll be done. Backups and restores, we can do it. We can do the manual option. We can export the database. We could DAC packet. We could DevOps it. We could do a number of things manually. I hate those options because I'm a lazy DBA and I'm human. I don't want to rely on human intervention to be able to recover from a disaster when it happens. But we can to take advantage of the native backup process to do restores. So we have that functionality. We can geo-replicate with Azure SQL Database, which is a step up in the right direction, in my opinion. I prefer failover groups out of both PaaS offerings, both Azure SQL Database and managed instances. Failover groups gives the most level of automation, which I'm a huge fan of. And I don't have to worry about, if this, in the middle of the night, the service can automatically detect, you can do other things with automation to figure things out. You can actually write Azure automation to, if you had custom metrics, you could write PowerShell or Azure CLI, slap that into an Azure automation account, and then have that automation to go do the failover, some metric, my application timeout is happening or whatnot. We're gonna go ahead and failover. So you can do automation things around that as well. As always, test and verify regularly. I just mentioned it earlier in the slide before. If you're not testing your DR, you're just begging for problems. Test it in some fashion, stand up a lower environment, a non-prod dev test environment, test it regularly. We often will do annual DR tests for our clients if they want us to. We actually have a service that we will offer our clients to do DR testing because someday you're going to need it. So test and verify. Questions, answers.
I don't see anything new in the chat window. So if anybody has any questions, please drop them in there. Otherwise, this is absolutely fantastic. The amount of real world experience in this is just incredible. And if you've ever started or you're working on your cloud journey, these are absolutely critical because you have to have this data. It's the first and foremost tenet of being a DBA is data protection. So these are words to live by.
Yeah. Yeah. DR is important, even in the cloud.
Yep.
It's not magically delicious unless you set it up that way.
Well, unless you set it up and verify and make sure and retest and test and fail over and et cetera, et cetera. So
yeah, my client, they actually they have a QA environment, and their QA environment has the exact same DR. Like they invest the exact, all their QA databases are in a failover group. And so we will actually go in there on a periodic basis, and they'll say, "Hey, John, go fail things over." Okay, click, fail over, and be done. And they'll test it. And they go they don't go cross, they go up and down. Their regions are north and south, but they do it. And I'm glad they do it.
You need to.
Oh, yeah.
I mean, if you don't test it, it's nothing more than an expensive space heater.
And you would know because you've got a big space heater in your house.
That I do.
And I was very, very ecstatic when my client came and said, "Hey, we want to set this up," because I've been talking to them about it. Like, "Hey, we should really test this." And we did, and we tested, and they were actually looking to verify that their application could actually handle. The infrastructure folks were looking to verify that the application could handle that transit because they didn't know. They're like, "Well, we don't know if that's going to handle that transient error, so let's go test it." See,
yeah,
we did, and it was. I mean, didn't even notice it. It was
as
cool.
It should be. That's awesome. So thank you very much.
Yeah, you bet. I hope it was useful. I hope.
Oh, it's incredible. Absolutely useful, absolutely words to live by for anybody that manages this kind of stuff. So if you're watching this after the fact on YouTube, do not hesitate to send John a direct message here through any of the means on the screen here. And if you have any questions for us, let us know. Otherwise, if there's any topics that you want to see, or if you want John back in the future, please let me know. We are here for you. If you have a good idea for a presentation, any of us that you see on the screen here, we will create a presentation for you and present this on here.
Yeah, that's no joke.
We do this all the time. I mean, somebody comes up with an idea for something. It's like, I haven't thought of it like that. Let's do this. So we'll do the work. We'll put a presentation together and we'll go out there and answer your questions. So thank you all for watching, either live or after the fact. And I look forward to the next one.
Awesome. Thank you so much for having me.